This is Gary Marr from Wayland Community College. This screen capture is for my SAS 150 AB Online students. In the screen capture, I want to talk about topics covered in Chapter 6 of our textbook, or specifically file processing. Now, I have a couple different examples here. One which is strict sequential file processing. A sequential file is simply text data inside of a file. You can typically open these up in Notepad and see all the characters just fine, as opposed to a binary file, which will show you a lot of nonsense. And these particular files are organized in a record format for transactions. So, in other words, if we open the one this particular example uses called team data, the positioning of the record, position of the data is by field. So, line 1 is the first record. The name of the team is Yankees. The city is New York. The second record is Astros, etc. Okay, that's how it's organized. That's typically how transaction files are processed, but there are variants of this. This particular example is going to open team data, the one I just showed you, to read access, and it's going to create a new file called newteamdata.txt for write access. There's also another access category called append, which would add to the end of the file. We're not going to worry about trying to make online or inline updates for this particular example. This is really just to demonstrate persistent data, files, how you would process those as transactional records. I've got two counters, team 1, or team is equal to 1, count is equal to 1. I'm going to start a loop here. I'm going to say as long as the team is not empty, in other words, there's still records in team, or still information in team, I'm going to process. I start off by saying team is going to be equal to what is in my data file on the first 19 positions. City is going to be the next 8 positions, okay, and then I'm also going to throw what's a line feed character control in there. This is a kind of a text file oddity, and it's a Python oddity. You may not see this. This is invisible information. If I was to go into my text editor and turn hex values on, you would see that after that team, city of New York, there'd be a couple special characters in there. The reason I have to deal with that is if I don't take and store it in that variable called x, what would happen is the information would write out correctly, or write out, but not correctly. It would climb across the page. And I'm not sure I'm going to show that today, but if you leave that out and run this in Python, you'll see what I'm talking about. This particular example is a Python example, but again, it's close enough to pseudocode, so I think it works for us. So here we have the first file called team data, and it's over here. It's got the team in the first column, and it's got the city in the second column. I am not sure why this is showing up the way it is here in terms of not lining up. I think it's something to do with the fonts, but I believe this will process fine. And once it reads a record into each one of these variables, so the first one would be Yankees for the team, city would be New York, it drops down here and it says as long as you have a team that you've read, in other words, it's not empty, there's a record there waiting, then what it's going to do next is it's going to take and print that record and its count, and then just basically show the information just read. But more importantly, it's going to put this inside a new variable called new data, and that's going to write that information to that file we opened for write access. It's going to continue to do this for all of the records in that file. It's going to create a new file called newteam.txt. When that looping is complete, there's no more records to run, it's going to close both files out. It's important that you close files after you're done processing. Not as much as it used to be, but it's just considered a good cleanup, good maintenance, a good standard to follow. In the old days, if you left files open, you could actually run out of available files and have other issues with programs you were trying to run alongside of it. That's less of an issue today, but what I would do is make sure you always have those close statements in there. I will certainly be looking for them in your assignments. This last example here is closer to what you're going to have to do for your assignment. Basically, you're going to read 2 files, and you're going to place that, or read 1 file, and place that information in 2 arrays. One's called fruit name, and one's called fruit calorie. And essentially what you'll do is after those files are read in, you're going to do a linear search of one array, looks like linear search is on fruit name, to get the calories. And essentially, this is very similar to what you're going to have to do for your assignment. You should be able to take the assignment from section 5 and then add the file reads into it, so that section 6's assignment should be relatively straightforward. I will probably have another example for that. I might even use this one here, but this should give you at least some exposure as to what it's going to be like in terms of processing files. You're always going to see an open statement that's going to open it for read or write. You're always going to have some sort of close statement at the end, which is going to close that file out. And then you're probably going to have a loop in the middle of that processing, which is going to take each record, a record at a time, and pull the information out of that record by column, or there's also comma or tab separated files, which means that the comma or the tab is the delimiter, and you'd pull the information out by a field and stick it in a variable for processing. This is pretty straightforward transaction processing, old school stuff, but still important for this class. If you have any questions, let me know.